Hello, we are looking at notes 2.8, which are in polynomial inequalities. So before we get into polynomial inequalities, I want to get into how to do linear inequalities. I feel like you guys are okay with single linear inequalities. You just solve it like a normal equation. But I just want to make sure you guys are okay with double or compound linear inequalities. So let's take a look at our first example here. Solve the following linear inequality. So if I have this piece right here, this is essentially saying that I've got one inequality here, and I also have another inequality here. However, I can be pretty efficient with my way of solving, and I can solve it all at once if it's a compound inequality like this. So let's go ahead and solve this problem. So if I have this 3 on the outside, I'm just going to distribute it through. By the way, it only works because I have constants on the outside and these are less than signs. Otherwise, this won't always work, just so that you guys know. Okay, so when I distribute this through, I get 6x plus 12. And then when I distribute this through, I get negative 2x minus 2. And I know that that expression is less than or equal to 46, but it's also greater than 30. Okay, now putting my like terms together, I end up getting 4x, and then here this gives me plus 10 is less than or equal to 46, but it's also greater than 30. Well, I want to get rid of this 10 right here, but if I get rid of this 10, I have to get rid of it everywhere. So if I subtract 10 here and I just get 4x, then I have to subtract 10 from this 30, and I also have to subtract 10 from this 46. Okay, so now that I've done that, I can just divide everything through by 4, every single piece. So I end up getting 5 is less than x is less than or equal to 9. Now, hopefully this should be just a review for you guys. Okay, so let's go ahead and graph this out on a number line. So if I were to graph this out on a number line, here's what my number line looks like. Okay, and obviously you want an arrow on both ends. And we know that our smallest value is 5, so I'm going to start at 4. And we know our largest value is 9, so I'm going to go a little bit farther past 9. I'm going to go to 10, okay? And this is saying right here that x is greater than 5. So I know it has to be greater than 5, but this right here is saying that x is less than or equal to 9, and it has to work for both of them. So it has to be less than or equal to 9 here. The only place that it's true for both of these guys is in between. So therefore x has to be between 5 and 9, and of course that's what this inequality is saying right here. So I would shade in between 5 and 9. Now if I want to write this in interval notation as an interval, it would be from 5 to 9, not including 5, so an open bracket on the 5, and including the 9, so a closed bracket on the 9. Okay? All right, number 2, the elevation of a hiking trail is modeled by the function h of x equals 2x cubed plus 3x squared minus 17x plus 12, where h is the height measured in meters above sea level, and x is the horizontal position from a ranger station measured in kilometers. If x is negative, the position is to the west of the station, and if x is positive, the position is to the east. Since the trail extends 4.2 kilometers to the west of the ranger station and 4 kilometers to the east, the model is accurate between negative 4.2 and 4. At what distances from the ranger station is the trail above sea level? So this right here is just going to restrict our domain. Okay, so all we care about when we look at this is from negative 4.2 to 4. Okay, so that's really the only information that I need to know with regards to this whole x is negative, x is positive piece. So I can really not have to worry about that at all. So at what distances from the ranger station is the trail above sea level? So again, it tells us that h of x is equal to 2x cubed plus 3x squared minus 17x plus 12. The first thing I'm going to do is I'm going to factor my function right here. So I'm going to write out possible a values. Okay, it's not all of them, but I'm going to make a list of some of them. So I'm going to look for factors of 12. So some factors of 12 could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now remember, I can take all of these and also divide it by 2 as possible a values, but we're going to start with this and then go from there, okay? So let's go ahead and see what happens if I were to just start plugging this in. So right now I'm just going to figure out what is h of 1, okay? So I'm going to use my graphing calculator to figure this out. You can also just use your regular calculator. I'm going to store 1 in as x, okay? And then I'm going to type in 2x cubed, so 2x to the power of 3, plus 3x squared, sorry about that, plus 3x squared, minus 17x, plus 12, and see what I get. My goal is to get 0 as my remainder. I do, so that's good news. So I know h of 1 is 0, therefore I can divide out this one right here. So this tells me that x minus 1 is a factor. Again, this is just review, but we got to go through the whole process in order to be able to answer this question. So put a 2 here, I'll put a 3 here, a negative 17 here, and a 12 here. Bring down the 2. 2 times 1 is 2. 3 plus 2 is 5. Hopefully this is easy for you now. 5 times 1 is 5. Negative 17 plus 5 is negative 12. Negative 12 times 1 is negative 12. Add those together, you get 0. So therefore, I can now say that h of x is equal to x minus 1 times, remember this is my remainder, this is the 1 degree, 0th degree, 1st degree, 2nd degree, so this is 2x squared plus 5x minus 12, okay? So now I need to factor my quadratic expression that I have here. So I know that it's going to have a 2x and an x, and I know that these two pieces have to multiply out to give me 12. So I'm going to try to put a 3 here and a 4 here and see if that works. This gives me 3x, this gives me 8x. 3x and 8x can give me 5x if the 3x is negative and the 8x is positive, so that works out nicely for me. So I can say this is positive, I can say this is negative right here. Okay, so based on that, I factored everything here. I can figure out the roots of my function. So I can say that the roots are x equals 1, x equals 3 over 2, or 1.5, and x equals negative 4. Okay, but here's the key thing that I need to make sure that I'm aware of. I'm looking for at what distances from the ranger station is the trail above sea level, which means that I want my h value here to be positive. So that means that x minus 1, I'm just taking this piece right here, times 2x minus 3 times x plus 4 to be greater than 0 because I want it to have a height that's above 0 in order for it to be above sea level, okay? So I know that when x is 1, when x is 3 over 2, and when x is negative 4, my height is going to be exactly 0. But the question is, what is going to happen in between these values right here? Well, remember right here, when I graph this out right here, if I were to look at it, I know that if it intersects at 1 and it also intersects at 1.5 and it intersects at negative 4 right here, and we have a positive leading coefficient, that it's going to end up looking something like this, right? And of course, I don't know exactly what the values are going to be, but I know that this is a rough sketch of what it's going to look like, correct? So based on that information, I can figure out, well, it's above sea level from negative 4 all the way to 1, and then it'll be above sea level again from 1.5 on. Okay, but how do I check this on a number line? Because sometimes you're not going to always want to graph everything out, but that is definitely an option that you have if you want to. Okay, so on my number line, I'm going to go from my smallest value. So my smallest root is negative 4. My next root is 1, and my next root after that is 1.5. And what I'm going to do is I'm going to just plug in some values here to see what I end up getting. Now, one thing that we have to remember, though, is that we have a restriction from negative 4.2 to 4. So that means that this graph right here will stop at negative 4.2, and we know that this graph right here will only go until we get to 4. Okay, so now that I figured that out, I'm going to do a bunch of calculations right here to see what I end up getting. So in this area right here, I'm going to figure out, well, what's h of some number between negative 4.2 and negative 4.1. So let's try negative 4.2 and negative 4. So let's try negative 4.1. So we're going to go to our calculator. We're going to store negative 4.1 in as x. Press enter, go up, highlight, bring it down. Right here I get negative 5.72. So this right here is negative 5.12. So I know that this is going to be a negative value. Anywhere between negative 4.2 and negative 4, I'll have a negative value. I only have to test one in between because this will tell me where my graph is. These values right here tell me where my graph is going to switch from positive to negative. Okay, so now let's try some value inside of here. Let's do the easiest value we can do, 0. 0 falls between those values. So when I plug 0 in, you should be able to do this in your head, right? Because everything will cancel out except for that 12. So you should end up getting 12, but let's just do it really quickly. So when I plug 0 in, copy and paste it in here, I get h of 0 is 12. So I know right here it is positive. Okay, now in this area right here, I need a value between 1 and 1.5. So let's try 1.25. So I'm going to store 1.25 in as x. And then I'm going to copy and paste this as well. Enter, enter, so I get a negative value, negative 0.65625. So I know that this is no longer unknown, it's a negative value right here. And then let's do one more right here. So this, in this area right here, let's choose any value we want between 1.5 and 2. Let's try 3. So when I do h of 3, I'm going to take 3, store it in as let's go down, sorry about that. Take 3, store it in as x, press enter, go up, copy and paste, it will let me, there we go, enter, enter one more time, we get 42, so we know that this right here is going to be positive, okay? Therefore, we can conclude that the elevation of the trail is above sea level for between negative 4 and 1. So negative 4 is less than x is less than 1, as well as 4x is greater than 1.5 but less than 4. So between 1.5 and 4. Okay? We have to stop at 4 because that's what our restricted domain tells us that we have to do. Okay? We're going to look at this graphically really quickly, and then we'll be done with this question. So I want to graph this out and see what ends up happening. So if I take a look at it, h of x is equal to 2x to the power of 3 plus 3x squared minus 17x plus 12. When I take a look at this, it's very clear to me that the graph is positive. It's above sea level between negative 4 and 1, and then it's also above sea level between 1.5 and 4, which are the answers that we ended up getting. Okay? All right, last question, number 3. Solve the following inequality. X cubed minus 2x squared plus 5x plus 20 is greater than or equal to 2x squared plus 14x minus 16. And we're going to use something called a factor table. Okay, so in order to be able to solve this, because I don't have a linear function, I need to get to a point where I have a greater than or equal to, or a less than or equal to, or this type, some type of sign here, but this side has to be 0, or at least one of my sides has to be 0. I'm going to get it on a side so that my leading coefficient is positive, so it's easier for me to deal with. So I'm going to get rid of the 2x squared here, so I'm going to subtract it. So the x cubed stays the same. When I subtract 2x squared from both sides, this becomes negative 4x squared. Okay, I'm going to subtract the 14x, so this 5x becomes negative 9x. And I'm going to add the 16, so this 20 becomes 36. And I want it to be greater than or equal to 0. Okay, now I can factor this using the factor theorem. However, when I look at this right here, there seems to be a lot of stuff in common, so I'm going to see if I can factor by grouping. So x cubed minus 4x squared has an x squared in common. When I factor it out, I get x minus 4. Okay, and then in this group right here, negative 9x plus 36 have a negative 9 in common. When I factor it out, I get x minus 4 as well. So I end up getting x squared times x minus 4 minus 9 times x minus 4. Well, these x minus 4s are in common, so I can factor that out. So then I end up having x squared minus 9 left over, and that's greater than or equal to 0 as well. This is a difference of perfect squares, so I can factor it even further. So I get x plus 3 and x minus 3. So all of these things, when I multiply them together, should be greater than or equal to 0. Okay, so that means I can conclude that my roots are 4, negative 3, and positive 3. Okay, so when I go ahead and do my factor table, what I'm going to do is I'm going to use it on a number line. I'll draw my number line up here, and I'm going to look at it from my lowest root, which is negative 3, to my next root, which is positive 3, and then I'm going to look at 4. Okay, so this is what I'm going to be looking at right here. When I create my factor table right here, my factor table is going to be based on these different sections that we have here. Okay, so my first factor that we have here is x minus 4. Okay, so I'm going to put x minus 4 right here. The next factor that we have is x plus 3. So I'll put x plus 3 right here. And then my last factor that I have is x minus 3. So I'll put x minus 3. But the operation that I'm doing with all of these is multiplication. So I'm going to put one last section in my factor table right here. And that last section is the product. I want to know what happens when I multiply these guys together. Okay, so here I'm going to test a value that's less than negative 3, right? Because this, I know negative 3 falls right here. So I want to test a value that's less than negative 3, so maybe I'll test negative 4. Okay, here I want to test a value between negative 3 and 3, so I guess I'll just test 0. Here I want to test a value between 3 and 4, so I'll test 3.5, and I forgot one column in my table, sorry about that. We also want to test a value that's larger than 4 right here, because this is where 4 falls, so let's test, I don't know, 7. Okay, so again, just choose values that are within the range or the domain that we're looking at right here. Okay, so when I do this right here, what ends up happening? So if I do negative 4 minus 4, I get a negative value. So this is negative. When I do negative 4 plus 3, I still get a negative value. And when I do negative 4 times or minus 3, I get another negative value. And this is saying that I'm multiplying all three of these values together. So it's a negative times a negative times a negative. So I end up getting a negative value. Okay? All right, so let's try the next column together. For the next column, I'm going to use 0. So 0, when I plug 0 in here, I get 0 minus 4, which is a negative. Here I get 0 plus 3, which is a positive, and here I get 0 minus 3, which is a negative. So this is a negative times a positive times a negative, so I end up getting a positive because these two negatives cancel each other out. Okay? All right, we'll do one more column, and then I'm going to have you do the last one. So here, if x is 3.5, if I do 3.5 minus 4, I get a negative. If I do 3.5 plus 3, I get a positive. And if I do 3.5 minus 3, I still get a positive. So here it'll be negative times positive, which is going to give me a negative. So I know this is negative. Please try the last column and then come back to me to see how you did. Okay, so when I plug 7 in, I get 7 minus 4, which is going to give me a positive. Here, when I do 7 plus 10, I get a positive, and when I do 7 minus 3, I get a positive. When I multiply all my positives together, I end up getting a positive. Okay, so that's our factor table, but what conclusions can I make from my factor table? Well, I want it to be greater than or equal to 0. So where is this true? It is not true here, so this is a no. Okay, it is true here, so this is a yes. This is not true. If it's negative, it's not greater than or equal to 0. And here it is a yes. Now, the question is, does it work at -3? So when the value is -3, does it work? Yes, because it has to be greater than or equal to 0. At -3, it is 0, so it works. Does it work at this 3 right here? Yes, it does, because it's a root, so it works because it's equal to 0. And then right here, does it work at the 7 right here? Absolutely, because it has to be equal to 0. Therefore, my answer is going to be, sorry about that, between -3 and +3. So it'll work everywhere from here all the way to here and everything in between, as well as from 4 to infinity. So therefore my answer is going to be -3 is less than or equal to x is less than or equal to 3, or x is greater than or equal to 4. Okay? If I were to write this in interval notation, then the way that this would be written is -3 to 3 in closed brackets, and then 4 to infinity. 4 is a closed bracket, infinity is an open bracket because I'll never reach that value. Okay? All right, we've got 8 videos done. We've got 1 more to go, and then we will be done with this unit. Have a good day.